Circular motion. So first of all, we're going to talk about radians. When an object moves in a circular motion, it will generate an angle theta. So that's an angle theta will be generated, or we might say subtended. So if I could draw from the center of the circle to any part of the circumference will be the radius. So that radius 1, so that's radius there, and another from center to there. So I've created sector. So that's a radius, and then subtended an angle theta. So I would say if I go from the green part here, from this part all the way around, the other way around, if I go like that, that's a major arc length. That's a major arc length. Or if I go the other way, from this point here all the way to that point, the red one here, and that will be the minor arc length. And the minor arc length will subtend an angle theta. So just to say that the subtend angle theta for the minor arc, but the major arc will subtend an angle alpha. So if I call the minor arc, I'm just going to call that angle, if I go from A to B in the red direction here, so that will be S subscript theta, because I'm saying displacement from A to B. In fact, that will be angular displacement from A to B. Or if I go the other way around, that would be S alpha. But also the green part here, the area there, is called the we call that the major sector. So that's a larger part here, that's a major sector. And the minor sector is a smaller one here, so that will be the minor sector. And if I draw another circle, just to describe what I'm going to talk about now. And before that, I'll just describe that we measure angles in two ways. We can measure angle in radians, which has a unit of rad, or we can measure angle in degree, which has a unit of degree. So pi radians is equal to 180 degrees, and therefore 2 pi radians is equal to 360 degrees. The circumference of a circle, circumference of a circle, is 2 pi r, and the angle of a circle is 360 degrees, which is 2 pi. So to build up a relationship between the arc length from, if I'm moving a circular motion from A to B, and the angle and the radius, I need to relate the minor sector to the whole of a circle. I'm going to write the I'm going to do a ratio comparison. Length, that's the arc length, over the angle. And that should be equal to, so the arc length here, let's call that S theta. So that will be S, that's the arc length from A to B, divided by the angle subtended by the arc length, will be theta, divided by theta. And that should be equal to the length of a circumference of a circle, so length over area, and that is 2 pi r divided by the angle of a circle, which is 2 pi. As you can see, 2 pi cancels 2 pi, and therefore from there it implies that r will be equal to S over theta, and therefore I can write the arc length from A to B is r theta. Or I can even write theta equals S over r. So that's the relationship of the angle subtended by an arc length, theta. So the displacement now from A to B will be that displacement. We're just going to call it angular displacement because I'm moving an angle to generate that. So the angular displacement is equal to theta. So that's the angular displacement. We go from there to there, the angle is being created. And the linear displacement is the arc length that we're talking about, is the S. So that means the length from A to B. That will be the linear displacement.